Make sure I share my screen. All right.
This is going on the YouTube live, right, sir?
Yes, it should be up already.
Sir. Watch it during the weekend, your YouTube videos.
Yes, I'll make sure that everything's up on both YouTube and eCanva. All right, so hopefully these are the things we will cover today. And I'll just put here test info. I did send out an announcement. I think it was last night, this morning. Just talking about your test will be it'll be available from the 20th to the 21st of October. So that is Thursday through to Friday. Friday from 12 to 12. Right, once you start, you'll have 3 hours to finish. It'll be 50-50, with half of it being theory and track, and it will all be on eCanva. Right. So, yesterday, let's just do over here what we've done. This, we've done basics of compiling and I/O. Then we've done variables and types, right? How to declare, etc. We looked at operators, arithmetic, and Boolean. Then we talked about control flow with ifs and nested ifs. So today we're going to finish, we're actually going to start with some control flow, some more control flow revision. We'll quickly look at switch statements as well as enums, but for now we consider all of these done. Okay. All right, so any questions before we begin? Any topics that we've already covered that you still don't understand? Feel free to ask now, and then we'll try to answer them.
I think I'm good.
You're okay? All right. You're free to interrupt me at any point if you have a question or if you need me to clarify. But for now, let's move on and let's quickly talk about switch statements. Right, so previously we looked at if statements, which was if A, then do something else, right, if A is false. Something like this. Then we found we could branch it out to say else if there's another condition like B, then do something else. Yes?
Sure, if you're doing an example of a code, why don't we just code it? Wouldn't it be easier if we could do that instead of drawing it the whole time?
Sure, yeah, but we can. It's better if we kind of discuss it on a higher level, and then you can practice the code on your own. Just because it's a bit more flexible when we're working through a whole bunch of different examples really quickly.
Oh, okay, so okay.
Yeah. So the idea being here is that if we had something like a variable x and we were checking different values of x, like different possible cases of x, instead of doing this, so else if x is equal to a, x is equal to b, x is equal to c, right? Something like this. We would use the switch statement. A switch statement, and we would switch on x. So this matches for every case. So then it's called switch. We open the bracket, and then for every case, so we add a little indentation, we'll say case. And in the case of x is a, then we can do something, right? So we'll say case x is a, then print something, right? We have some sort of statement, and then we'll usually say break, right? Case b, and so on, right? And then break. And then we have something like a default. Okay. So I actually have a question for you. Why do we put the break statement in here? So the answer here is to prevent something called fall through. With switch statements, if we get a match on some arm, so let's say we get case B, right? If we didn't have this break here, and we had something like case C down over here, what would happen is, without a break, the match would happen, we would hit case B, and we would start executing, and we would keep executing everything until the end of the switch statement, or until we hit break. Okay, this is something called fall through, right? So a switch statement will fall through, literally keep going, unless we put a break statement in. Now, I also mentioned something called the default statement. So the default statement is what is is the equivalent to an else statement in an if, right? So with if, we have a whole bunch of conditions, and then else statements don't actually have any other conditions. An else if would have like a condition, but an else statement doesn't. So in a switch statement, this is equivalent to the default case. Okay. And in the same, sorry, that's a colon. And in the same way that the else statement means that we didn't match anything here, so does the switch statement. So we say if x doesn't match any of these cases, then we'll execute this code in the default statement. Why do we not? Yes, go ahead.
But I like the if else always reminds me of try and catch. Like at first tries it like the if at first does the code, and if it doesn't do that, it will do the other things. So similar to the try and catch. Like a try first tries out the code, and if something's not wrong, it will do the catch statement.
Yes.
Like it's
so yeah, that's close, because an if statement will check the expression first, whereas the try will run the code, and then if something's wrong, will give you a catch. So the
catch is basically a nicer way of saying there's an error. like the catch that it says that there's something wrong with the code, but it just doesn't give it in that horrible
Yes.
exclamation, like all that other word.
Yes, so it lets you resolve the exception, right? So this would be an exception type, usually call it E. And the reason why you get the horrible like crash reporting is because you have an uncaught error, and by default the Java program will crash, will give you an error message. Yeah. So yeah, ifs, try, catch, and switch statements are all very similar in structure, but their application and the context that they're used is a little bit different. Something else I want to touch on when we talk about switch statements, when we're testing for multiple values of something, right? We might sometimes use something called an enum. An enum, the term enum is actually short for enumerate. And does anyone want to guess what enumerate means? Whenever,
That's just what I said.
say again.
I was being silly. It's okay.
Oh, okay. No, you can try it again if you want. I just didn't hear your joke. So.
I said, what is enumerate? So I said it's enum, and
Oh,
I realized with the day.
Yeah, it's in there. Yeah, so it's almost like the things like a recursive statement, like what does PHP stands for, and PHP stands for PHP Hypertext Protocol, right? Like it's a recursive acronym. So enum stands for enumerate. Yeah, so that's a good one. But actually, in reality, enum means to make like a numbered list, right? To enumerate things is to give things a number. So with an enum, when we define an enum, we are defining a new type. So we'll call this like days, right? And what we're saying is that anything of this type has a limited number of possible values. So whenever we say days, it can only be either Monday or Tuesday or, Wednesday, and so on and so forth. So there's only 7 possible values for anything that's a days type. So then if we have like a variable, we can say day and today is equal to, and the way we assign values to this enum is like this: days dot what's today, Friday, make it a real example, days dot Friday. Okay, so what we're saying here and what the compiler can look at is that today is only one of 7 possible values. So they work really well with switch statements, where we have something as follows, and this is why enums are quite useful. We have something as follows where we can say switch on the R today, right? So switch on today, and then case, and we have all of these over here. So case day dot Monday, right? We say, oh no, and then we break. Case today, or the day is Saturday, we slack off, right? And if we want fall through, we say case without a break, day is Sunday, we prep or whatever. So because we don't have a break statement, if it's Saturday, it means we want to slack off and prepare. Whereas if it's Sunday, we just want to prepare. Okay. Is everyone okay with enum switch statements before we move on? Let me just check if there are any comments. Yeah?
Touch up. Just like a quick touch up on both, like an end off
For
the enum and switch, sir.
okay. Yeah, so an enum is a user defined type. A user defined type with a predefined set, so a set of possible values. Okay, so an enum is we kind of describing our own type in much the same way that a class is a type and an interface is a type. An enum is also a type, but it has a limited set of possible values, okay, like a predefined set. With a switch statement is a way to check if any values match the expression. So with a switch, we have our what we call controlling expression, which is in here. And then we say with the cases, we can match any possible values of this expression. So in most cases, we put a variable in here, like x, and then we check for values of that variable. However, you can actually put expressions in there. And then the default will catch if any of these didn't match. So if this is case B, and if x is anything but A or B, then the default will work. And by the general behavior of a switch statement is once it matches, it'll continue executing until it hits a break statement. Okay. Is everyone okay with that? Does that make sense?
Yes, sir.
Okay, excellent. So let's quickly have a look at our list here. So now we're going to look at loops. We have a couple of loops, and loops are a way for us to kind of repeat the same set of instructions over and over until some condition occurs. So all loops have a condition, right? So a condition that controls the loop. So we have a couple. We have two main ones, which is a while and a for. Let's actually do it like this. So we have a while and a for loop. Let's move this up. And the while loop is the simplest, because a while loop will just check if the condition is met. So while, and this has to be true. While true, we execute whatever is in the body. Okay. The danger here is that if we don't update this condition, so if this is x, right? If x is never true, this loop will go on for infinity. It'll just keep looping and looping and looping and looping because the condition that is checking never changes. So at some point, x has to be equal to false for us to then exit this loop. All right. So it's really simple to do, but we can get it wrong and it will loop infinitely. Right? So that's a while loop. A while loop like this, in this form, will check the condition first, then execute the code. So this will be second, and this will be first. There's something else. There's a variant of the while loop called a do while, which works a bit differently. A do while loop looks like this, where we say do, open brackets. We have some code, and then at the bottom here, we have our while statement. While this condition. So a do while loop will execute first and then check the expression. All right. So there are two forms for the while loop. The one is the standard form, and then we have a variant, and the variant is the while. Okay. A do while loop also ensures that it will be executed at least once. A while loop can execute 0 or infinity times. Okay. Next, we have a for loop. So a while loop doesn't have an easily definable number of iterations. It can either be 0 or it can be infinity or somewhere in between. And a do while can be between 1 and infinity or somewhere in between, right? With a for loop, the form is a bit different. So with for, we have this. We have a big old expression like this. And there are essentially 3 sections separated by semicolons. The first section defines the variable. The second section defines the condition. And the third section defines the update, or the iteration. Okay. So with a for loop, we will have something like, in most typical forms, int I is equal to 0. So this creates the variable. And so we say the loop variable is I. If while I is less than 10, this is our condition that gets checked at the beginning of every loop, I++. And this gets executed at the end of our loop every single time. Okay, so these are our 3 sections over here. And then we execute some kind of code. With for loops, because we have an update, we only need to make sure that if the update keeps happening, eventually this condition will be false. So a for loop, it can loop an infinite number of times, but it's a lot more difficult. We just need to make sure that the update of the variable will eventually make it false. Okay. What's nice about a for loop is then we have this variable I that will start off at 0. So in the first loop, it will be 0. Then the next iteration, it will go ++. So it go from 0 to 1 at the end, right? So when we hit this bracket, we do I++. And it will go from 0 to 1. And then the next iteration, 1 goes to 2, and so on, until I is 10. All right. When I is 10, then it's no longer less than 10, and the loop exits. Okay. So with a for loop, we also have a slightly different format. And that format is called the for each loop. All right. So let's do this, clean it up a bit. So there's a for each loop, which does the following. It's most useful for things that are iterable. So when we iterate, we loop over, right? So we create an iteration. Then the for each loop looks something like this, where we have a type, or actually it's better to describe it this way. We have the some sort of array, right? So we can either have a primitive array or an array list. It doesn't really matter, but we have some sort of array or a collection where there's a number of elements and a sane way to get through them with some sort of type, right? So each element in this array is of a specific type. And then we can declare a variable type of the elements in the array. What this does is it goes through every element in the array and it copies the value. It doesn't point to the actual element in the array. It copies the value into X. So if our array has a length of 5, it'll copy our values from 0 to 4 into X and then execute this body. All right. So it's a lot simpler to write, and we don't run into the potential for infinity because we know it'll only go through all of the elements one time. All right. Is everyone okay with that so far? Any questions about these loops?
So basically, it don't go on forever because you said it's 5 only.
Yeah. So because we know what the length of the array is, and we can know what the length of the array is at compile time, or at least at runtime, determine it, it will only touch every element once, and it will copy the value. You won't actually access that value directly, or the element directly.
Yes, sir.
Okay. So we have two different while loops. Now we have two different for loops. The regular for, the normal for loop, and then the for each. Okay, we call it a for each loop because that's how you can describe it. So you can say for each element in the array, do the following. All right. So this one has the potential for infinity. This one does not. With this one, you can actually access values in an array and change them. With this one, it copies the values. Okay. So if we're in a loop, and at any given point we want to get away from it or break out of it, we say break. Okay, so break over here escapes the scope. So if we have a for loop, right, in a for loop, everything happening in here is the for scope. So if we say break, we immediately want to get out of that for loop. Okay. The same with a while loop. So we can just change this to while. Okay. So break will immediately exit a loop, and then the program will continue afterwards. Then there is another statement that you should know, which is called, if we had a for loop, which is called continue. Have you encountered continue before? So when you say continue, it says if we're running through the code and we reach continue, stop right there and immediately restart the next, or immediately start the next iteration. Okay, so that's what continue means. Break escapes. Continue says immediately go to the next loop, the next iteration. Is everyone okay with that?
Yes, sir.
Okay, awesome. So that's loops done. Let's have a look here. Control flow, loops done. All right, let's talk about arrays now. With arrays, they are blocks of data. So given a type, the way to define an array is you say the type, and then you put two hugging square brackets. You give the identifier or the array name, and then to instantiate an array, so this over here is the declaration, and then to instantiate or initialize, we say new, we give the type again, and then we give the size or the length, right? So the number of elements in the array. Okay. So when we do this, what happens in the memory, which is a big block of data, is it goes and it looks up like, okay, what is the size of this type and how many do I need? So if we say it's an int and we need 5 of them, it'll create space for 5 integers. So it'll go like this, and I'll say, okay, this is a space for an int, this is a space for an int, this is a space for an int, and so on and so forth. Now we have 5 integers stored in memory. And then what it does is it says, okay, I will grab this memory address and I will store it in array name. So this is the memory address. Okay, pretty straightforward. To access elements, we will say array name, right? And then we give the index. And that will go over here, and it will go starting from 0 to the length of the array. In this case, it's 5 minus 1 is 4. And so it will just access those elements. Pretty straightforward. However, you cannot, you have to be careful when you create arrays and compare arrays. So if we create a second array, and we call it array 2 is equal to array name, right? What this is doing is it's just copying this address into this variable. So if you then say array 2 and try to access a index, what will happen is this will follow to this memory address and access that element directly in memory. So if you change this element, it will also be changed in the array name array. Okay, so this is something we have to be careful with. Also, because these two, array 2 now contains the same memory address as array name, what would happen if we said the following? Array 2 equals array name. What will this give us? What's the output of this?
Would it be an error, so would it be exactly the same thing?
So they are the same thing, which means you'll get true. Okay, so this will return true. However, instead, if we say array 2 is a new array of type with also the same number of elements, I think we said 5, right? So integers, 5 integers. What will this statement give us?
False.
False, exactly. Because now we've created a second array in memory, like this, with a different address, and that address is now stored in array 2. So this operator just looks at the address and says, are these two the same address? And they're not, so this returns false. Okay. So when you're working with arrays, you should always make sure that you're copying the values or checking the values if you're trying to make sure arrays are equal, right? Then there's kind of two other ways that arrays work, or at least two things that can happen with arrays. When we first get an array, right, and say it's an array of numbers, it'll look something like this, or an array of strings is probably better. When we create a string array, saying new string with a number, so I think 5, or there's 6, like this. What happens here is that these strings aren't yet created, so they're empty, right? And then say we want to gradually fill this array. So these are 1, 2, 3, 4, and 5. These are the indexes. If we want to gradually fill this, we need to keep track of where the next open spot is. And the way we do that is that there is the number of elements, or the count of elements. So we keep track of this, and when we create it, the count is 0. As soon as we add a string, right, we say count plus plus, right, we increase by 1, so now the count is 0, count is 1. And a side effect of this, like keeping track of how many elements, is that the count always points to the next available spot in the array. Right. So then if we were to add a new string, and we wanted to do it in a reasonable fashion, we can say, okay, add it into index 1, and then we'll say count plus plus. When we say count plus plus, so let's add that string. We'll, I don't know, make it a smiley face like this. And then when we say count plus plus, count now becomes 2, which points to the next open spot. Okay, so this is an example of how to deal with something called a partially filled array. And then as part of your assignments, you did two things. You said is empty, and is empty is if the count is 0, and is full is if the count is equal to the length of the array, right? Because if the length is 6, and let me just do this. If the length is 6, that means that once count is 6, it's pointing to uninitialized memory. Okay, it's out of bounds. All right. Everyone okay with that? Any questions? Okay. Now we can finally talk about something called array lists, which are much easier to use. Array lists. And an array list is declared as follows: array list. I think it's also the library you import is java.util.array list. So you need to import this library first. But then you say array list, and you have to give it a type. So let's just call it a string type. The name is equal to new array list. And because we have done generics now, we can actually just use the diamond here, because the diamond will infer the type over here. Okay. An array list is a little bit different. With an array list, we just kind of get a blank space of memory with the array list, and we need to use the array list methods. So the name dot get, and we have to get an element at some index, or name dot insert, and we have to, insert an element of a string. Okay, so it's a little bit different. The array list also has different properties. I think it's size, like this, and count as well. So you can get the size and the count of the elements in the array list. I will refer you to the Oracle documentation. It's got an extensive documentation of all the possible methods and all the possible methods and attributes of array lists. The benefit of array lists is that we can very easily use our for each loops that we learned, right? So the type of the element in our array list, right? And this will cycle through it quite easily. You can also sort array lists pretty easily and search and look for things in the array list. All right. Array lists are really flexible, really nice. The big trade-off is that we don't really get to directly index things, so we can't just kind of do that, and it takes up a little bit more memory. Okay. Any questions so far? Because I think with that, we are sorted with arrays. Right. Arrays and array lists, done. Let's have a look at basics of object-oriented programming. So, object-oriented programming, we start changing our thinking from just like data structures and variables and like arrays. We zoom out a little bit, and we start modeling things in terms of classes and the idea of objects. So we have something called a class, right? And a class is an idea like a person or a car. Oof, I don't know if I can draw a car. Let's call it a bakkie then. A person or a truck or a car or whatever, right? So that's like to refer to an idea, and it serves as the blueprint. So a class has a whole bunch of things related to it, and then we create something called an object. Okay, and an object is something that we can interact with directly. So in Java, when you declare, so a class is also a type, right? So it's a type of thing. In Java, when you declare, you use the class name as the type. So let's call it my class. And you have your variable name is equal to new my class, right? This, once we've instantiated it, this is referred to as the object because it's something we can interact with. And this is referred to as the class. So this is the class. That's actually a bit confusing, so we'll do it like that. Okay, so a class is a blueprint used to create an object. All right. Now, let's talk about in a class. So in Java, all classes are types. So a class is a type. Put that up there. When we have a class, and I'm going to use the UML diagram for a class, or a UML class diagram, a class always has a name. So we give it a name. And the convention for writing class names is the first letter capitalized, as well as every word. Name to be used. Right? I believe this is called Pascal case. Okay. So Pascal case is used for class names. And then we have the internal variables. And the internal variables of a class, if it's like a person, they have attributes. So a person has a name and a date of birth, right? All sorts of data that relate to the person or the thing we're modeling. Those are called attributes. So we have attributes over here. And all of those attributes are either public, private. I should actually do this outside of the class. Are either, we denote how they can be accessed, right? And when we do this with the access, and we have private, public, and in Java we also have protected, right? When we control how and what variables get accessed, this is part of encapsulation. Encapsulation, say it like that. And the idea of encapsulation, or otherwise known as information hiding, let me actually do it here. Info hiding, right, is for security. So we need to make sure that people aren't messing with the internal state of our object in an uncontrolled way. So all of our attributes can either be public or private or protected. Okay, so we can have our name is public. And what does it mean when something is public? It means it can be accessed, if this is the class. It can be accessed outside of the class, and it can also be modified outside of the class. So we can change it from outside of the class. It's not just accessible. If something is private, it is only accessible inside of the class. And if something is protected, it is only accessible inside of the class and any subclasses. Okay, so this is protected. Right. So we have attributes which contain the data or the internal state of our class. And then we have the behaviors. Behaviors. And behaviors are also called methods in Java. methods in Java. Okay, and behaviors can also be public, private, or protected, right? So these won't be accessible outside of the class. Only the protected, the public methods will be. So when we have a bunch of methods and public attributes that are visible from outside of the class, we call that the class interface with a small I. So the class interface is all of the publicly accessible methods and attributes. So you can think of it as the class, like this, has a barrier, and everything private is accessible in here, but the public methods give you like buttons on the outside. And the public variables give you like little readouts with buttons that you can change the variables on, right? So it's like an interface. Think of it like a keyboard. Okay. Is everyone with me? So this is the class, and this is the interface with a small I. So it's all the public methods and attributes. Is everyone still with me? I see we have 15 minutes left, so I should probably hurry up a bit. So that's OOP basics done. And now we're going to look at methods and attributes, specifically methods and how you write them. So with methods, you have the access modifier. So let's do our classic, we'll start over here, public, void main. Okay. This, and then this is. So you should hopefully be familiar with this. Okay. So this is a method. When we look at the access modifier, so we'll break this down. This is the access modifier. This is also a modifier. Right? This is the return type. This is the method name. And then this over here is the parameter list. And each parameter, which is separated by a comma, so that's the separator, has its type and the name of the parameter. Okay, so when we take all of these things together, right, if we have all of these things together and then the whole parameter list together, we get the method signature. And Java requires that all method signatures must be unique. Must be unique. Okay. So that brings us to overloading and overriding, which we'll discuss next week, Monday. I think I'll stop there for today and open it up to any questions, any comments. But yes, so we'll stop here, and then next week we'll pick up from overriding, and overloading. Methods. Any questions so far? Anything you want me to go back over or cover, or something you don't quite understand? All right. If there are no further questions or comments, feel free to enjoy your Friday. Good luck with submitting your assignment, and I will see you Monday. Feel free to email me if you have any other questions or something you want me to go over in a bit more detail. But otherwise, I will see you Monday. We'll have a lecture Monday, we'll have a lecture Wednesday, and then Thursday will be your test. Or Thursday, your test will become available. All right. Otherwise, take care, have a wonderful weekend, and I will see you on Monday. And best of luck with your test preparation and your study.
Okay, sir. Thank you so much. Enjoy your weekend.
You're most